Hello, we're going to do a lesson today with quadratics solving by graphing. So we're going to solve quadratics by graphing, and I apologize for the handwriting with this program I'm using. So it's going to be worse than normal for my handwriting. Okay, so if you remember from doing quadratics before, that when you have a graph of a quadratic, it makes a parabola. And there are three different situations when you look at that graph as far as finding the solutions to that quadratic equation. So your parabola could possibly look like this, where it crosses the x-axis twice. So when that happens, and this is what happens most commonly, you have two solutions. And we also can call solutions the roots or the zeros. Those are all interchangeable terms for the types of for solutions to any type of graph. It's where it crosses the x-axis. And if you think about things that cross the x-axis, the value of the y is 0. So those are also the x-intercepts. So lots of different ways to describe what's happening when a graph is crossing the x-axis. So those are the solutions or the roots or the zeros to the equation. It's the x-intercept, the y equals 0 at those places. So if your parabola looks like that, where it's crossing the x-axis twice, it has two solutions. Or it could be a frowny parabola, two solutions. So that's one possible situation. Another could be something like this, where, and I didn't draw that very well, but just the vertex is sitting on the graph. So it only makes contact with the x-axis in one place at the vertex. And so that would be one, and I should have used the word real earlier, one real solution. When you have a polynomial, which is what we have with quadratics, that's a polynomial, the biggest exponent tells you how many solutions you have. So quadratics, the biggest exponent is a 2. That means we should have two solutions. Well, it looks like here that we only have one. We have one real solution, but it actually counts twice. It's called a double root, and you'll get into that more in Algebra 2. So what you would really want to concentrate on is there's only one real solution or one real zero or one real root for that. So we had a parabola that crossed twice, two real solutions, parabola just the vertex touches, one real solution, and then the third situation would be if the parabola did not cross the x-axis at all, like that, or maybe like this. The way the arrows are pointing, that parabola is never going to hit the x-axis. So when that happens, we say we have no real solutions. And it's important to use the word real because there's such a thing as imaginary solutions that you'll get into in Algebra 2. And so these parabolas that don't cross the x-axis, they still have two solutions, but they're imaginary solutions that you'll deal with in Algebra 2. So for now, when it doesn't cross the x-axis, we'll just say no real solutions. Okay, so let's look at some practice problems for solve by graphing. And we'll solve these on our graphing calculator. Now this little calculator that's just popped up, that's the free Texas Instrument on your computer calculator that you can use. I posted links to those in our resources section of our classroom. I think Miss Sims did as well. There are versions if you have just a regular laptop, or there's a different version if you have a Chromebook. I have a Chromebook, so that's this version, and it seems to be working really well. So even if you don't have a graphing calculator at home, you can download these free, they've made them free for now, versions from Texas Instruments, and they'll work just the same. So everybody should have a calculator, and you can email us if you, me or Miss Sims, if you have any issues at all with doing that. Okay, the first example we're going to do, oops, I just messed that up. I don't know how to erase. There we go. Okay, so our first example to graph, solve by graphing, is x squared minus 11x plus 24 equals 0. We want our equations to equal 0 so we can find the zeros. We can find where it's crossing the x-axis. This already is. So we're ready to go to y equals. And then in y equals, I'll put the equation. So x squared minus 11x plus 24. And just to do the standard 10 by 10 window, I'll push zoom and then 6. So you can see how the parabola crosses the x-axis 2 times. Oh, it won't write on top of this calculator. Okay, that's all right. So it crosses 2 times, and so we need to have the calculator find those 2 places for us. And the buttons you need to push are second and then trace. And we want option number 2, which is 0. Okay, it's asking for the left bound. So we want to put the cursor to the left of one of those places where it's crossing the x-axis. I'm going to do the left side first. I don't see my cursor, but if you look, it tells you where your cursor is. It's at 0.24, which is way up high on the y-axis. So I'm going to push the right arrow, and you can see it coming down. Y equals 16, y equals 14. It's coming down. There it is. So I want to be to the left of the spot where it crosses the x-axis. Hit enter. Then make sure you cross over. Now I'm to the right where it says right bound. Hit enter. And then you always just hit enter when it says guess. So x equals 3 is one of my solutions. Now I need to do that all over again. Second and trace. Choose number 2. And I'm going to scoot around. Come on. So now to the left of where it's crossing the x-axis would be about right there. Enter. Go to the right. Enter. And enter when it says guess. X equals 8. If you get an error, it's likely that you got your left and right backwards, or you did it on the left side twice in a row or on the right side twice in a row. So just kind of start over if that happens. So those are our 2 solutions. If we plug those values in for x in the original equation, worked it out, they would both make that be 0. Okay, let's try another one. Hang on. Okay, our next example is negative x squared minus 7x minus 6 equals 0. So it said equal to 0. Now our first example was a right side up, a smiley parabola. And this one is going to be a frowny. I want you to think how we know that. How do you know if it's going to be a right side up or a flipped over parabola? So if you remember the a value, remember how a quadratic equation follows this form. And the coefficient for x squared, the a value, if a is positive, you'll have a smiley parabola. If a is negative, you'll have a frowny. So in this example, our a value is -1. So our parabola is going to flip over and be a frowny. So let's plug that in, y equals, clear that out, negative x squared minus 7x minus 6. And again, I'm going to try zoom 6. That's just the standard window. And you can see your frowny parabola, and you see it crosses the x-axis 2 times. So second trace and number 2. Zip around here. I'm going to do the far left one first. So I need to put my cursor to the left of where it's crossing, and then hit enter, go to the right, enter, enter again, x equals -6. Now, if it comes out to be a decimal, that's okay. I don't remember if any of my examples do, but if it comes out to be a decimal, you can just round it to, let's say, 2 places. Now we need to do it all over again. Second trace, and choose number 2. And we need to move the cursor to the left of the place where it crosses, and then to the right. So x equals -1. So we had 2 real solutions because the parabola crossed the x-axis 2 times. Okay, let's try another one. (5x squared minus 18x minus 27 equals 8. So this one's not quite ready to go. Look at that for a minute and see if you can think what's going on with that, why we're not quite ready. And the reason is that it's not set equal to 0. So we need to move the 8 over so that it's set equal to 0 before we start. 5x squared minus 18x, and then -27 minus 8 is -35. Okay, now that's ready to go. So into y equals, think about, is this going to be a smiley or a frowny? 5x squared minus 18x minus 35, zoom 6. Okay, we can't quite see all of the parabola. And really that's okay for what we're doing because we only need to see where it crosses the x-axis, and we can. But it's good practice to learn how to adjust the window so that you can see. We already determined that because the 5 is positive, that it's going to be a smiley. So if we want to see the whole parabola, we need to go down lower. So the way you would do that, if you push window, the up and down, the high and low would be the y's. So if I want to go down lower, I need to go to y minimum. And I have no idea right now how low I need to go. So I'm going to make that go down to -50. And if that's not right, we'll come back and try something else. When I change numbers in the window, I usually change the scale as well. And I just chop a 0 off to do that. So because I've gone to 50, I'll make my Y scale a 5. It just makes it look nicer if you do that. And then you're not going to push zoom 6. That would turn the window right back to where it was. We're just going to push graph. Okay, we almost can see all of it. So if you really need to see all of it, which you would if you wanted to figure out what the vertex is or the minimum, you're going to push window. Let's go down. We could go down even to 100. -100. And so if I chop off a 0, the Y scale would be 10. Okay, that looks good. But because I need to find the zeros, maybe I want to see more of it up top. So let's do one more adjustment. Window, let's go with Y max maybe to 50 and see what that does. Okay, wonderful. It crosses twice, so we need to find both solutions. Second trace, choose 0, Going to go to the left of where it crosses, enter. Come on, enter. There we go. Then to the right, and enter when it says guess. So negative 1.4. Hang on. I'm trying to change colors. Okay, there we go. And then I need to do it again. Second trace, choose number 2. And I need to be to the left. And hit enter, to the right. Enter again. And x equals 5. Okay, wonderful. Next example. X squared equals negative 2x minus 5. So again, it's not ready to go. We'll need to move the 2x over. We need to move the negative 5 over so that it all equals 0. So we need to add 2x and we need to add 5. X squared plus 2x plus 5 equals 0. So y equals, clear that out, x squared plus 2x plus 5, zoom 6. So we know it's a smiley. The number in front of the x squared is positive. But if it's a smiley and it looks like what we're seeing on the screen, it's not ever crossing the x-axis. So that's the situation where you have no real solutions. And again, that word real is important. Okay, let's try a couple more. Let's do negative x squared minus 20x minus 1 equals 0. And honestly, I didn't try this one out first, so we're going to see what happens here. Y equals negative x squared minus 20x minus 1. Let's try zoom 6. Okay, so we cannot see, we can see one place it crosses, but we can't see any of the rest of the parabola. So we know it should cross twice. We know it's a frowny because of the minus. So we're going to have to adjust the window quite a bit. It looks like, if you think about a frowny parabola, it looks like what we have is part of this side. So I think we need to make the window go farther to the left and farther up. So if I push with the window farther to the left, that would be the x minimum. Let's make it negative 50 just to try. And if I chop a 0 off, then the x scale would be 5. If I need to see up higher, that would be the y maximum. Let's try 50. Chop the 0 off, scale of 5, and let's see how that looks. Okay, it's better. We can see where it's crossing the x-axis. We can't see all the way up high. And let's make it go a little lower as well. So let's make it maybe go, and I just experiment, and if it gets too wonky, just start completely over. Okay, so I tried the y maximum at 100, chop the 0 off, y scale would be 10. Okay, so we can pretty much see the whole thing. You don't have to see the vertex to be able to do the zeros, but it's handy to learn how to be able to adjust the window to see everything, because sometimes you need the vertex. Second trace and 0. So I need to go to the left and then to the right. Negative 19.95 if we round to 2 places. And then do it again, second trace 0. So it's to the left, we hit enter, to the right, negative 0.05. Okay, great. All right, let's do one more. And so we've got 0 equals 2 times x minus 3 squared. So it's just written in a little bit different form, but it's still quadratic because we still would have the x squared into the y equals. It's already set equal to 0. 2 parentheses x minus 3 parentheses squared. Zoom 6. Okay, we can see the whole thing, and this time it looks like the vertex is just resting on the x-axis. So when you find a 0 with the calculator, it wants to be above the x-axis one time and below it another, but we're all above or right on. So if I try to do second trace and choose 0, and I'm to the left of it and I hit enter, and then I go to the right and hit enter and enter it guess, it gets mad at me because we didn't ever cross the x-axis, and you don't need to if you're on, if your vertex is right on there. So let's go back to the graph. You can do a couple of things about that. You can zoom in, but that if it's a decimal answer, it's not going to give you really what you need. If I zoom in, then I just put my cursor where I want to zoom in and hit enter. And so it looks very much like it's at x equals 3, and sometimes that's the best you can do. But another thing you can do is use the table feature of your graph. And the table feature is on this top row, the farthest right button. So if I put, now what I want you to remember is when you're when you're on the x-axis, the y value is 0. So what we're looking for, our point is a point where the y value is 0. So second, and I push the graph button. And if I look at my table, where y is 0, the x is 3. So that helps me also see what it looked like that the x was 3. And again, if it's a decimal, you would have to make some adjustments to your table to get decimals. You're not going to have to do any of that. But for now in Algebra 1, if you just want to eyeball it, if the vertex is just sitting right on the x-axis. Okay, that's it for this lesson. Thanks for listening. Okay, I know it's still recording. I need to stop it. All right. Bye, y'all.